Hi, everybody. We're going to be talking about simplifying rational expressions today. Um, Sorry about the quality of the camera. I have a really old camera, so bear with me. It's a little bit blurry. But we're going to be talking about a rational expression, which is a ratio of two polynomials. And first thing we're going to talk about is what a domain of a rational expression looks like. And the domain of a rational expression is all real numbers except for where the denominator is going to be equal to 0. And that's important because we know that in a fraction, we can't have division by 0. So that's why the denominator is the important part of our rational expression. So if we want to look for the domain of the following expression, again, sorry about it's a little blurry, the expression x plus 5 over x minus 4, we need to set the denominator equal to 0, and that's going to be what values we want to not include in our domain, which should be kind of familiar from Algebra 2 because we did this a little bit when we were talking about rational expressions. So if I set my denominator of x minus 4 equal to 0, that tells us that the value of x equals 4 is going to be not included in our domain. And there's a couple different ways that you can write this. If we think about set notation or interval notation, we can either write this as the union of the negative infinity to 4, and then we're skipping over 4, and then unioning it with the 4 to infinity. So this is basically saying I have a domain of all real numbers except I'm skipping over 4. Or if you prefer set notation, we can say x is the element of all real numbers, but x cannot be equal to 4. So there's a couple different ways that you can write that, and either way is acceptable. So for the second expression here, the denominator that we're worried about here is the 2x plus 4. So if I set 2x plus 4 equal to 0, move the 4 to the other side, so I get 2x is equal to negative 4, divide by 2, I get x equals negative 2. That would tell me that my domain is, again, all real numbers, except that x can't be equal to negative 2. So we're going to be talking about incorporating the domain into our problems when we're simplifying or multiplying, which is kind of what we're going to be concentrating on today. So the first thing that we're going to talk about is simplest form, or getting a rational expression into simplest form, which basically means that the numerator and the denominator aren't going to have any common factors other than 1. And there's a couple of different steps that we can use to simplify. The first thing that we usually do is factor the numerator and the denominator. And then we want to list the values that are restricted from the domain. And then we would want to cancel out any common factor. And then our final answer is going to be made with the restrictions that we list in step 2. So if we look at our first expression here down at the bottom, this is giving us x squared plus 5x over x squared plus 8x. And usually when there's just like a 2-term expression here, I look for a GCF, or greatest common factor. And it looks like our GCF in both the numerator and the denominator is going to be an x. So I'm going to factor out an x from the top. That's going to leave me with an x plus 5. I'm going to factor out an x from the bottom, and that's going to leave me with an x plus 8. So from here, I want to take my denominator and I want to set this equal to 0 to get my restrictions. So x times x plus 8 equals 0. This is a product here, so I can separate this to say x equals 0 or x plus 8 equals 0, which means that x equals negative 8 is going to be a restriction. So these are going to be our restricted values when we write our domain. So once we figure out our restricted values, we want to go back up to our factored form and cancel out any common factors, which it looks like I have an x and an x that I can cancel out here, which leaves me with my answer, because now I have a simplified expression and I have a factor of x plus 5 in the top. I have a factor of x plus 8 in the denominator. And I'm going to list this with the restrictions that I got up here where I say x can't be equal to 0 or -8. So my simplified expression is this, and then my restricted values, the values that my denominator would, or that would make my denominator 0, would be these two. So our second expression here, our second example, leaves us with x squared minus 2x minus 15, and then x squared minus 9. So I'm seeing that this is a trinomial that I would want to factor, and then this is a difference of two squares. So if I factor up here, I'm going to get an x, looks like -5, and an x plus 3, because I'm looking for factors of -15 that add to -2. And then in my denominator, difference of two squares factoring pattern leaves me with an x minus 3 and an x plus 3. So here's my expression that I want to now say, all right, I'm going to figure out what my restrictions are by setting my denominator equal to 0. So x plus 3 and x minus 3. Separate those out, set the x plus 3 equal to 0. Separate out x minus 3 equal to 0. And it looks like my restrictions are going to be x equals -3 and x equals +3. So then I'm going to go back up and I'm going to say, okay, do I have anything in common here that I can cancel? In this case, I have a factor of x plus 3's. So my simplified rational expression is going to be x minus 5 over x minus 3, with the restriction that x cannot be equal to -3 or +3. All right, so that's kind of basics on simplifying. And now we're going to be talking about multiplying rational expressions, which kind of has some of the same steps that we're going to be talking about when we were simplifying. But we're going to go back to Algebra 2 for a second, because we did exponent rules where we actually did multiply out rational expressions. And there's a couple different ways that you can do these. Remember that you can work like within one fraction to start, or you can multiply across numerator and denominator and then simplify from there. It just kind of depends on what your preference is in terms of the number of simplifying steps that you want to do. But the way that I like to do this type of problem is to multiply across the numerator and multiply across the denominator and then simplify afterwards. So I'm going to look for my like terms here. I have an 8 times 7. That's going to give me a 56. And then remember, exponent rules say that if you have an x to the third and you're multiplying by an x to the fourth, you add your exponents together. So that's going to give me an x to the 7th. And then here I have a y to the first and a y to the third. So if I add those together, I get a y to the 4th. And then my denominator, like terms, I got a 2 and a 4, so that multiplies to 8. I only have one x term, but then I have a y squared and a y to the first, so it's going to give me a y to the third. And then from there, I want to look for like what my like terms are here. Here I can definitely divide 56 by 8 evenly, which is going to give me a 7. Remember that when you have an x to the 7 over an x to the first, technically, remember that you can subtract these exponents. So 7 minus 1 is going to give you an x to the 6. And then a y to the 4th over a y to the 3rd. If I subtract 4 minus 3, that's going to give me a y to the 1st, or just y. So it looks like our simplified expression is B. And the reason that this is kind of helpful to see is because this is actually a process that you can use to multiply rational expressions. Or like I was saying before, you could actually just simplify what's on each term of the fraction instead of multiplying across. So whatever method you prefer, that would work for when we're going to be multiplying rational expressions. And I've actually lined up some steps that we're going to follow here. I always start by factoring any sort of numerator or denominator if it is factorable. Multiply out the numerators and denominators, kind of like what we did up here. We're going to multiply across, and then we're going to divide out any common factors. But remember that we want to make sure that we're giving any restrictions as well. So I'm going to start with my first numerator here. So 3x minus 3x squared. This is just a two-term binomial, so it looks like I have a GCF of 3x. So when I factor that out, I'm left with a 1 minus x. My denominator, Looking for factors of -5 that add to +4. So that'll give me, let's see, x plus 5, x minus 1. I'm going to multiply that by my factors up here. So it looks like I'm looking for factors of -20 that add to +1. So x plus 5, x minus 4. And then my denominator here, I don't have anything to factor, so I'm going to leave it as 3x. So I'm going to do the same thing I did above, and I'm going to multiply across my numerators, meaning I'm just going to basically take all of these factors and just put them into one numerator together. So 3x times 1 minus x times x plus 5 times x minus 4 all over. I'm going to rearrange a little bit, so I'm going to put the 3x out front, and then I'm going to multiply it by the x plus 5 and x minus 1. And here's where I'm going to do my restrictions, because now that I've got this into one denominator, I'm going to figure out what my restrictions are on my domain. So that's going to be 3x times x plus 5 times x minus 1. Set that equal to 0. Separate those out using the zero product property here. So this is going to give me, I think, an x of 0, an x of -5, and an x of 1. So here's going to be my restrictions that I'm going to list at the end. I'm going to go back and see if I can cancel anything out between my numerator and denominator here. It looks like I have the 3x's here that I can get rid of. I have a factor of x plus 5 that I can get rid of. And these are a little bit tricky because a lot of people think that these are the same thing, but they're a little bit different because here the 1 is positive and the x is negative, and here the x is positive but the 1's negative. When that happens, what you can actually do is you can, when the signs are completely opposite, you can actually take this numerator factor and we can actually factor out a -1. So if I factor a -1 out, that's actually going to change the sign of this negative or this +1 into a -1, and it's going to change the -x into a +x, which is actually exactly the same thing. Now I have a -1, -1, +x, +x. So I can cancel these out as well. And what I'm really left with after I do that is I'm going to have this -1 that's left over on the outside. And then it looks like I have a factor of x minus 4. And then it looks like my denominators actually are all gone because I've factored or I canceled out all of these things. So here's where I'm going to put my restriction. So I have this -1 times x minus 4, but I know x can't be equal to 0, can't be equal to -5, and it can't be equal to +1. So here's my expression that I'm left with. So let's try another one. Number 6 is kind of same idea. We're going to walk through the same steps. So it looks like my first numerator I can't do anything with. I'm going to leave that. My denominator, 5x minus 20, I've got a GCF here of 5 that I'm going to take out. So I have x minus 4 that I'm left with. And then my numerator, x squared minus 4x, I have a GCF of x that I'll factor out. So I'm left with an x minus 4. And then my denominator, I'm just going to leave as x. So then I'm just going to combine these into one single fraction together. So this leaves me with a 4x times x minus 4. And then I'm left with a 5. I'm going to bring this x over x to the 5, and then I'm left with an x minus 4. So here, I'm going to figure out my restrictions. So I have a 5x times x minus 4. Set that equal to 0. Use my zero product property. Separate those out. And it looks like my restrictions are 0 and +4. So when I go back over here to cancel things out, it looks like I actually have one factor of x that I can get rid of here. And I also have these x minus 4s that I can get rid of, which really just leaves me with a 4x in the numerator and a 5 in the denominator. So my simplified expression is actually just 4x over 5. My restrictions, x can't be equal to 0 or 4. All right, and last example, same idea for this one. We'll go term by term. There we go. So 2x squared minus 10x. Looks like I have a GCF of 2x that I'm going to bring out. I'm left with an x minus 5. Denominator, this is a difference of two squares. I've got two perfect squares, so this is going to factor into x plus 5 times x minus 5. My numerator, I'm going to leave that as a quantity of x plus 3. And then I don't have anything to do with 2x squared, so I'll leave that as it is. Then I'll go ahead and bring these all over into one fraction together. So 2x times x minus 5 times x plus 3. And then I'm going to bring this 2x squared out front, and then I have an x plus 5 and an x minus 5. So my restrictions, again, are going to come from here. So 2x squared times x plus 5 times x minus 5 equals 0. So 2x squared equals 0, x plus 5 equals 0, x minus 5 equals 0. If I divide by 2 and then take the square root here, my x value is just going to be 0. Here it's going to be a negative 5, and here it looks like it's going to be positive 5. So I've got 3 restrictions here. And then I'll go and see what I can cancel over here. So it looks like I can cancel out a 2. Here I have an x in the numerator, and I have an x squared in the denominator, so I can actually get rid of one of those x's. So this x in the numerator is going to go, and then the power of 2 here is going to go. I'm still going to have one x left down here, though. And then it looks like I can cancel out a factor of x minus 5 top and bottom. So what I'm left with in the numerator looks like it's just going to be an x plus 3. And then in the denominator, I have that x that was left over, and I have an x plus 5. And then my restrictions, I'm going to say x can't be equal to 0, negative 5, or positive 5. All right, so it's going to be your turn to do some practice on this simplifying. Let me know if you have any questions.